My name is Megan Withers and I'm a PhD student at Monash University, and my FameLab presentation is titled Diagnosing the Earth's Most Complex Compound Fracture. Okay. The Earth's upper crust is similar to a human bone. Both are strong, but both are brittle. If I were to fall and the force of that impact exceeds the strength of my bone will snap and fracture. And this is exactly what happens in the Earth's upper crust when forces from opposing tectonic plates exceed the strength of a rock, except we call that snap an earthquake and that fracture a fault. Large earthquakes rip through the Earth's crust and break the Earth's surface, similar to a compound fracture of the bone and skin. However, when the Earth breaks, there's no doctor to put that fracture back in place. And this leaves major deformities that form weak points in the Earth's crust. And these weak points will snap again and again. Over time, this generates large faults, the most significant of which form our Earth's tectonic plate boundaries. Now, part of the Australian Pacific plate boundary runs through South Island, New Zealand. But it came as a surprise that the 2016 magnitude 7.8 Kaikoura earthquake did not occur on the large fault that forms that major weakness in the region. Instead, the earthquake bypassed this major weak link, leaving behind the most complex surface rupture pattern ever recorded and displacing the Earth vertically by up to 9 meters in the process. The Kaikoura earthquake is therefore the Earth's most complex compound fracture, and my research aims to provide a diagnosis for why this earthquake was so complex. To achieve this aim, I'm trying to understand how the major faults in the region have developed. Now, I can't do this in real time because I don't have the next 8 million years to spare. So instead, I'm trying to recreate the Australian Pacific plate boundary in a scaled down model in the lab. And this model consists of a 20 by 40 centimeter box filled with sand. And I'm able to run this scaled down model over a 1 hour time period, which is a little more effective for finishing my PhD on time. Now, as I run the model, the sand grains in the box are exposed to forces scaled to those acting on South Island, and these forces cause faults to develop in the sand. And just like a doctor would to analyze a fractured bone, I use X-ray images to see inside these models, allowing me to identify and monitor these faults developing in the sand. Analysis of these X-ray images so far shows that the location in the crust that is experiencing the greatest tectonic force has been migrating southward through time. And in present day, this location is now far enough away from the major fault in the region that this major fault no longer breaks. So perhaps this is why the Kaikoura earthquake did not rupture this major fault. And therefore, a diagnosis for the Earth's most complex compound fracture is that a new major plate boundary fault is now in development across South Island. Thank you for listening.